any problem from 1 through 20 that's just driving you crazy?
Yes.
Okay, what is it?
19.
Yeah, start it off.
19, 20, 17, and 13.
Okay, we're not doing all those.
Damn it.
So pick one.
Which one gave me the biggest headache? 13.
13?
No. Just do 19, yeah, just do 19.
Okay, let's go with 19. That looks crazy. Okay, I kind of want to do 6. Did anyone do 6?
Yeah.
Was it hard? I don't think it was probably that hard. I think the idea for 6 is you just kind of have to do 2 problems. And you have to find out where the first parabola is going up and down, and then you have to find out where the second parabola is opening up and down. Or actually, well, yeah, you basically have to do 2 wiggle graphs for 1 derivative, because there's 2 different derivatives to that derivative. Okay, the derivative of this, real quick, number 6, and Ishmael, I'll come back to yours. The derivative of this, by the way, okay, think about conceptually what's going on here, okay? And I'm trying to break this up so you guys can do some work in between me talking, but I'm probably going to talk a lot today because there's a lot of good problems in here, and this is basically the lesson plan, because I doubt that everyone did it, and I doubt that everyone got everything right, and these are really worthwhile problems. So the derivative of a piecewise function, remember, the derivative is just the equation for the slopes. So if this is the equation for the curve when x is less than 0, then the equation for the slopes is going to be based on this curve. So it's real simple. You're just going to go minus 2x for x is less than 0. This is going to have the same exact domain because while we're on this curve and the part of this piecewise function, the slopes are the slopes of that curve. And while we're on this part, the slopes are the slopes of that curve, and that would be 2x. Which is kind of weird because that's like an absolute value thing, right? That reminds me of like... Can I get that book? Yeah, sure. Because if you think about the graph of this, it goes like this. Right? Does that make sense? Maybe?
Yeah.
Depends on how much you know. Yeah. Okay, so anyway, this would be y prime for that. Okay? And, interestingly enough, the only 0 for either of these is 0. Right?
Yeah.
So, and I can't, I'm just thinking, what does this graph even look like? 3 minus x squared is like this, and x squared plus 1 is like that. So isn't it something like this? Does that make sense? Right? I mean, the reality is that the answer is always super close when it seems far away. Did I graph it right?
Yeah.
Right? So anyway, what I'm thinking is, what does it say? First derivative test. So basically you have this thing from 0 to the left is negative. When you put in a negative, you get plus. And then to the other one, when you put in right of 0, because both of the zeros are 0, you put in right of 0 here, you're going to get plus. Right? Does that make sense?
Yeah.
And so...
That's just a regular parabola.
Huh?
It's a regular parabola.
What's a regular parabola?
No, regular line.
Yeah, because it's going up and it's still going up. So the point is this function is always increasing. The only thing is it has a weird jump at 0, right? So... I mean, there aren't going to be any absolute extrema. If anything, I guess you could say that this looks like a local min. Does that make sense? But I don't think you had to do that because it's at absolute extrema. So basically, the first derivative test tells us nothing because it never changes from plus to plus or minus. I mean, plus to minus or minus to plus, right? You remember that's the idea of the first derivative test. So therefore, you could just put none. I would imagine. Be done with that problem and sort of support your answer graphically, but there's no absolute max or absolute min of this, right? Because obviously it goes above and below. Yeah.
It's asking for a local extreme.
Oh, okay, I see. Right. Well, unfortunately, I don't understand how the first derivative test would tell us that. The only one I can think of is what's that?
Does you want to know which graph is which?
derivative function. This is the original function. So yeah, I mean, the first derivative test doesn't really tell me any of that, unfortunately, right? So I mean, the only thing I can see is this, but I don't. I mean, I would just say, I don't know. That's all. We're done. What else do you want me to do? Can you imagine anything else?
Nope.
First derivative test doesn't tell me anything. Is my point. Basically, the main point I can make. The only zeros is 0. 0 is not even in the domain of this one, so you really can't even use it. The only thing we can really do with like a wiggle graph is that. It's just not a very interesting piece there. I don't like that problem very much. But anyway, moving to number 19. I'm definitely going to mess this up. So when I was in tutoring yesterday doing a couple problems, like I said, I was 0 for 2. So what I would prefer is if you guys would like kind of watch me and catch my mistakes, because I'm probably going to make one eventually on this crazy problem. Do you want to make sure that we can't simplify that? Because it would be easy to do that.
Nope. I tried.
Did you try it?
Oh, wait, yeah. No, wait.
I don't think it's going to work because that would be really lame if it did. But I'm motivated to try it by my own.
Yeah, nah.
No, there's a remainder. So, okay? Does anyone know why I did that?
Yeah, because you're trying to factor.
Because I'm looking at that crazy rational expression there, and I'm thinking maybe I can make my life easier by dividing and getting a polynomial. But it didn't work out, right?
Nope.
So now that means we're going to have to take 2 derivatives of that crazy thing. And this is definitely not going to be fun, but that's all right.
Math
We'll do one
isn't
problem
fun.
that's not at all fun. Actually, let's do it on here because it makes my life easier. Hello. You're welcome to work on any other problem you want to work on while I'm going over this, unless, like I said, you've done all of it, in which case, you're best. Take a break. 19 is x cubed minus 2x squared. Plus x minus 1 over x minus 2. So, this is annoying. Let's go. Only hope I have, I guess, the quotient rule, yeah? 3x squared derivative of the top times the bottom. I'm not going to multiply that together because I'm hoping it will factor out somehow or something will factor out somehow. But I might have to multiply it together later. Minus the top times the derivative of the bottom, which is x cubed minus 2x squared plus x minus 1. Again, help me out, because if I make a mistake, it's going to ruin everything. You're going to be all mad at me. It's probably going to be your fault. Okay, so times 1, which is just what it is, right? Everybody with me so far?
Yeah.
Over x minus 2 squared, right? Okay, that sucks. Now, sometimes I might tell you, don't simplify that, it's a pain, it's going to take a long time, whatever. But the problem is, of course, is that if I don't simplify it, then I have to take the derivative of that, which is going to take forever. So I am going to actually go ahead and try to simplify it, which would be 3x cubed, oh my god, it's going to take forever.
Yep.
Minus 6x squared, minus 4x squared, plus 8x plus x minus 2, right?
Uh-huh.
Which is 3x cubed minus 10x squared plus 9x minus 2. Minus, and then I'm going to distribute the minus over here, which is a common mistake if you didn't do that. X cubed plus 2x squared minus x plus 1. So that whole top comes out to 2x cubed. What? Minus 8x squared. Is anyone following me? Minus, plus 8x. Minus 1. Over. That? Oh, this is the worst problem ever. find concavity? Oh, points of inflection. So second derivative equals 0, right? Or it does not exist. By the way, don't forget about the does not exist part, because I forgot about that yesterday. Yeah.
I do.
So I gotta do this again? Who's with me? No one? Do I have to?
Yeah.
Okay, so let's do it then. 2x, no. Seriously. 6x squared minus 16x plus 8. You swear. What's the point of this? Who makes this stuff? Alright. Now what? Minus 2x cubed.
What?
I'm about to quit. Plus 8x minus 1
Yeah, it's crazy.
times x minus 2. Okay, times. Okay, we'll do the chain rule because it'll be easier. 2x minus 2 to the 1 times 1. And we're done. With that.
Over.
Over x minus 2 to the 4th?
FML.
Yeah, what the heck?
I'm getting smaller, it keeps growing.
I know.
Wait, can't you factor out our next minus?
Great. I can, which actually does help a little.
But not tons.
Well, why don't I just cancel it then? 3, one of these is gone, and that's gone. Does that make sense, everyone?
Maybe.
It's better that way. Am I doing it right? Hey, you don't know.
Do it.
Pay attention. Just watch me if I make a mistake. I kind of want to just get the solution.
Your mistake was trying.
No, to do it. It's
No, because
temptation.
I want to see if we made it. If we got it right so far.
No, it's temptation. Do it.
All right, fine. But did you guys help me? Did I do everything? Did I
Yeah, so far.
Okay.
Sure,
so
why
what
not?
should I do?
Simplify?
Multiply?
Yeah.
Okay, so 6x cubed for the second time now in this stupid problem. I have to do a 6 multiplies. 12x squared minus 16x squared plus 32x. You guys watch me, because if I make a mistake, we're all going to be pissed. I don't know, because I was trusting you to catch me.
Hold on. You got
6x squared times 2. I just went 1, 2, 3, 4, 5, 6.
That was great.
Right?
hold on.
Yeah, that's right.
What I'm going to do is take this negative with this 2 and multiply it in. So it's going to be minus, oh wait, crap, hold on. Let me
FML.
simplify first. 6x cubed minus 28x squared plus
40.
and then I'm going to subtract, okay, so 4x cubed, and then there's going to be plus, because it's a negative 2 times 8, 16x squared. Anyone who's watching me do this, don't worry, you don't really have to do this. It's just like follow along. But just make sure I'm not making any dumb mistakes. Negative 16x, does that sound right?
Yeah.
And minus 2? No, plus 2.
Plus 2.
Good, thank you. So this is 2x cubed plus, no, minus 12x squared plus 24x minus 14. Oh, God help me. Is that right?
I don't think God heard.
Is that right?
Yeah, still checking.
Okay.
Shit. Yep.
Is it right?
Yeah.
Okay. So I got,
No, wait.
what
Go back.
uh-huh.
16x minus, it's 40.
Yes.
Okay, yeah.
I do it right?
Yeah.
Okay, that's stupid algebra. So 2x cubed minus 12x squared, what is this?
Plus 24.
Plus 24x minus 14
Yeah.
over x minus 2 cubed.
Yeah.
I can factor 2 out of the top, I know that much. X cubed minus 6x squared plus.
Wait, can't you do some distance?
Well, I can try.